Hello my dear students, this is Akash SD and welcome to the ASD physics classes. So I hope so you all are watching my videos regularly because regularly I am updating the videos, and as of now I am teaching the gravitation, and till now in gravitation I have completed the 4 parts. Okay, 3 parts recorded video and 1 part it was the live class here. So students, today we are going to see the part 5. In that we are going to learn everything about the gravitational field intensity. In short form I will tell GFI. So first we will learn what is the gravitational field, then we will learn how to represent the gravitational field in a mathematical form, then we will see gravitational field intensity due to different bodies. Is it? At the same time we will learn equilibrium concept, resultant concept also. Okay students, so let's start the video and let's learn something. Okay students, so let's start it here. So students, here the first topic is the gravitational field. So you can see the gravitational field, it is the space around a mass within which it can exert gravitational force on other masses. And here I have written which kind of force? Non-contact force. Please remember that one thing. This field concept will be always applicable for the forces those are non-contact in nature, like gravitational force, electrostatic force, all these things. Okay, then after that you can see here mathematically gravitational field intensity and gravitational potential are the quantities that gives the information about the gravitational field. So first let me draw here the gravitational field, and mathematically which physical quantities we will take. One is the gravitational field intensity, this will be vector quantity, and gravitational potential, it will be the scalar quantity that we will see in the next video. Okay students, so here let's take for example, here I have taken one point mass. Now this point mass is m. Now the space around the mass, the space around this mass capital M, if we put some other masses, then what will happen? It will experience the attractive force here. Is it? So why this is happening? This is happening because this capital mass M is having its own gravitational field here, like this here. Okay, and arrow will be in which direction? You know gravitational force is always attractive. So in the same way, in the same fashion, the gravitational field intensity will be also towards the mass, and even this gravitational field also towards the mass here. This is the gravitational field due to point mass capital M. Now after that, if I take here one hollow sphere here. Okay, so hollow sphere here, in case of hollow sphere what will be there? If I draw here the gravitational field, so gravitational field, it will start from the infinity and it will end up at the mass like this here. Okay, like this in a symmetrical fashion here, like this here. So this is for the which one? This is due to the hollow sphere here, hollow sphere, and here inside what will happen? The gravitational field intensity I will be how much? 0. Even sometimes instead of I we use the term E also. Okay, so this is for the hollow sphere. Similarly, if I do for the solid sphere, which one I am telling? Solid sphere. Even you know our earth is also solid sphere here. Okay, so let's take for example here, this one here, this one I have taken. Solid sphere. Solid sphere means how to draw here? This is the solid, that means like this here, solid sphere. If due to this I want to draw the gravitational field, then how it will be there? Like this here, see it, please, like this, like this, like this. Even inside also field will be there, like this, like this here. Okay. This is due to which sphere? This is due to solid sphere, like any planet also. This is the gravitational field diagram is there. Okay, and even you can see at the center what is happening, all the fields will cancel out each other. That means at the center only what will be there? The gravitational field intensity will be 0. This is due to which sphere? This is due to solid sphere, and the previous one was due to hollow sphere here. Okay, now students, after that we are going to learn the mathematical concept and all. Okay, so let's see here please. We are going to see the gravitational field intensity, and as I told you, this is which kind of quantity? Vector quantity here. So let's see here students, see gravitational field intensity at a point P is defined as the gravitational force exerted on unit mass at that point. Okay, so gravitational field intensity due to mass capital M at point P is given by, so first what I will take here? I will take here one mass capital M. Okay, and here at this point P, I want to calculate the gravitational field intensity. Okay, so I will draw here one vector. This is called the position vector r. Okay, and in this direction, let's take unit vector is r cap. Now, and this r cap is given by vector r by mod r here. Okay, now as I want to calculate the gravitational field intensity at point P. Okay, so here I will take here one mass small m, test mass here. Now after that, you know very well, capital M will attract the test mass small m. In which direction? In which direction? In this direction here. In this direction, is it? So this will be the direction of the gravitational field intensity. Even we are going to see also now here. Okay, so according to the definition, we can write gravitational field intensity at point P is given by gravitational force per unit mass here. So I will write here F by m. Okay, even I will put the vector sign also. That means you can see very well the direction of the GFI and the direction of the force will be same. Okay, now after that, students, here please here 1 by m. Now, and here the gravitational force formula, very common, G capital M small m by r square. And here we have to write the unit vector. In which direction? In the direction of the force. Force in which direction? You can see the force in this direction, the direction of the force and the direction of the GFI will be same. So you can see this I in which direction? In the opposite direction of the r cap here. Okay, opposite direction of the r cap here. So I will write here minus r cap here. Okay, so what will happen? This m and this m will cancel out. Then we can write the GFI at point P in a vector form, Gm by r square minus r cap. And this minus r cap is very, very important for the graph point of view and all that. Even sometimes if we have to write only magnitude to solve the numericals and all, now so we'll write here this I mod I, or we can write just I is equal to Gm by r square. Okay, so this is the just a mathematical representation of gravitational field. And which physical quantity is there? GFI. Okay, students, next one please. After that, see please, important points. As I told that GFI is a which quantity? Vector quantity, and is always directed, highlight it please, towards the mass whose GFI to be measured here. Now SI unit, you know GFI means force per unit mass. So here the SI unit will be what here? Newton per kg. For GFI, always use Newton per kg. Even you can write meter per second square. But meter per second square, we will never use it. Never use it meter per second square. Always use Newton per kg. After that, dimensional formula, just like a acceleration dimensional formula. So what can I tell here? The dimensional formula will be m power 0, L power 1 and T power minus 2 here. Okay, now students, as of now we have seen the GFI due to a single mass. Now we will see for multiple masses here. So let's see here, GFI at point P due to masses m1, m2, m3, mn is given by here. So first I will write here some masses here. This is m1, this is m2, this is m3. So many masses are there, and here mn here. And I want to calculate the GFI here at this point. At this point, I want to calculate the GFI. I have taken point P. Okay, students. So what will happen here? See here, please. From the mass to the point P, we will draw here one line like this. Because why? GFI and force is the which force? Central. That's why we have to draw all this line here. This also one line. This also all this line. And here also one line will be there here. Okay. After that, we will draw the direction of the forces here. Let me draw here the direction of the forces. So here, see here. What I told you, GFI is along the direction of the force. So here I am drawing here the direction of the GFI here. So this one here, I1, this one here, I2 towards the mass. This one here, I3, and this one, this is also I4. They all are which quantities? Vector quantities here. That means the resultant GFI at point P is given by resultant GFI at point P I am writing. Okay. So in a vector form, I1 plus I2 plus I3 plus dot 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 plus IN. Okay, so this will be the resultant GFI. Okay, please see it very well. After that, students, let's see here please. Now we are going to see cases of GFI due to multiple masses. Even the last video I have uploaded for the Coulomb's law. Now, so there also this concept I have used in that video, Coulomb's law application, because the concept of gravitation is used in 12th Coulomb's law here. Okay, so if in case you have seen this video, then you can go and watch Coulomb's law video also. Here you can understand very easily, because in 12th lot of basics has taken from this gravitation chapter. In the chapter electric charges and fields. Now, so here please, here I have taken the two masses here. As of now, one mass was there. Now I will take the two masses here. Now, so here please, this is mass m and this is mass m. Okay, this distance is L, this distance is L, and this distance is L. Okay, and I want to calculate the GFI here at this point. Now, and let's take this point is P. So you know very well what is the direction of the GFI. The GFI is always directed towards the mass here. Now, so let's take this is mass 1 and this is mass 2 here. Okay, so see here please here. Due to first mass, GFI in this direction, I will write here I1, and due to second mass, GFI will be in this direction here. What to write here? I2 here, and here I will just make here one parallelogram here. Now, so resultant will be in which direction? The resultant will be along the diagonal like this here. Now, like this diagonal here. Now, like I will write here IP here. Now, so you can see very well here, this I1 and I2 both will be equal in a magnitude, because mass is same, distance is also same. So I1 and I2 will be what here? Just here please here, Gm by L square here. Correct? Gm by L square. Now, small m I have taken. Now, after that, you know very well. Now, this intensities are all same, so I will write here I. So now, if I want to calculate the resultant intensity at point P, the formula 2I cos theta by 2, all this basics I have talked in a last video, Coulomb's law applications here. So can you see here please, this angle, how much students here? This angle is 60 degree here now. So I will write here, see, 2I and cos 60 by 2 cos 30, that means 2I cos 30 degree value, how much here? Root 3 by 2, is it? Then this 2 and this 2 will cancel out. We can write here what? Root 3I, now resultant intensity. That means we can write here root 3 into Gm by, what is there? This one here, Gm by L square here. Now, so this is the resultant intensity due to two masses at point P here. Okay, good. Next one, students, we are going to see the case 2. Case 2. In case 2, what we are going to see here? Here we are going to take the three masses here. Now let's take here M, M, and this is also M. Okay, and let's give the names also here. 1, 2, 3. Now, and here I have taken point P. At this point, I want to calculate the GFI here. Okay, so see here again L, 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 and L. Now, can you guess at point P how many GFIs will be there? 3 GFIs will be there. See here please here, 1 GFI this side here, no, due to 3 mass here, I3. 1 GFI due to mass 1, no, just 1 minute, like this, no, this one what you write here? I1. And after that, one more GFI will be there. In which direction? Along the diagonal. See here I have drawn the diagonal here. No? So then after that here, if I write here one more GFI, so one GFI will be in this direction here. What you write here? This GFI will be I2 here. No? So here how many GFIs are there? 3 GFIs are there. Okay. Now if I want to calculate the resultant GFI, which GFI I am telling here? Resultant GFI at P. So what this will come here? See please here. This resultant GFI at point P is given by I1 plus I3 plus I2. In which form? Vector form here. So students, what we will do to get the resultant of 3 GFIs, first we will find out the resultant of these 2 GFIs, I1 and I3. Now, first we are going to find out for this, then the resultant of these 2 GFIs we will add with the I2. Okay. So let's take, I will write here, this one I have just taken here I dash, and this will I will take here I2. Now, so first I am going to find out the I dash here. Now, so students, let's see here please. Let me write here the values. Now, this I1 and I3 will be, this I1 and I3 will be same, just like a previous one. How much here? Gm by L square, and this one I will write here how much? I. Okay. After that, if I write here the value of this I2 value how much here? See please, I2 equal to Gm by this distance how much? From the Pythagoras theorem, L root 2. Is it? That means we can write here this one L root 2 whole square. That means what this will become here? Gm by 2L square. And here I can write here I by 2. Okay. Now students, what we have to do, as I told that, first I will find out the resultant of which one? I1 and I3 here. Now, so here please here. Resultant of I1 and I3. What I given the name? I dash here. Now, so that resultant is given here. See here please, this I dash is equal to, again formula, 2I cos theta by 2. And can you see the angle between I1 and I3, how much here? This one here, 90 degree here. Now, so we can write here, see please, that 2I cos 90 by 2, that means cos 45. Cos 45 value how much? 1 by root 2, is it? So we can write here 2I into 1 by root 2. So it will come here what? Root 2I, or we can write here root 2. Value of I how much here? This one, Gm by L square here. No? Okay, let me write here, no problem. Now, can you see what is the direction of the resultant of I1 and I3? Just draw here the parallelogram here like this here. So you can see here the resultant will be in this direction I dash. Now after that, the resultant of I1 and I3, that means I dash, is along the direction of I2. That means the angle between I dash and I2 how much here? 0 degree. That means if I want to write here the resultant of all of them. Now resultant of what I am telling here, I dash and I2 is, just let me see here which point number is there. That's why I am writing the point wise, so that you should not get confused here. Point number 5 here. So what this will become here? The resultant GFI is given here. First one, we are writing here I dash, and after that I2. Now I dash how much? I dash how much we got here? Root 2I, and I2 how much here? I by 2. I by 2. Now students, just simplify this here please. Hence IP is equal to, take I common, so root 2 plus 1 by 2. If you can put the value also of I, so root 2 plus 1 by 2 Gm by L square. This is the resultant GFI at 4th vertices of a square. Okay. So after that, after seeing the cases and all that, students, we will see some equilibrium concept and all that. Let's see here please. Now students, see please, very important concept. Even in 12th also I have taught recently. So see here please here. Equilibrium of a mass m0 or null point between two masses m1 and m2. So students, you have to remember that one thing. Equilibrium means what is 0? Equilibrium means the force is 0. Equilibrium means what is 0? Force is 0. And the force will be 0 wherever GFI is 0 here. That's why if the force is 0, what will happen that here? The GFI will be also 0 here, and that is called the null point here. So wherever null point is there, anyhow force will be 0 and the equilibrium concept will be applicable here. Okay students, so let me just take here the two masses here. Let's take here. This is mass m1 and this is mass m2. Okay, and let's take they are separated by distance d. Okay, now after that, let's take at a distance of x. At a distance of x from m1, what is there? The force is 0. Force is 0 means what we can tell? GFI is 0 here. What is 0? GFI is 0 here. Even you can keep mass m0 also, no problem here. So let's take here. Here what will happen that here the force in which direction? Attractive force, that is called what to tell here? The force. So see here please, force. This is F01, and here also what is there? F02. Is it? Both the forces, arrows should be equal here. So equilibrium means what will happen that here? Equilibrium means the forces will be balanced. So see here please here. F01 is equal to F02. F01 is equal to F02 here. Okay. Now after that students, as the forces are balanced, that means what will happen? The GFI will be also there. But see, I will show you here. See, Gm1 m0 by x square is equal to here m2 and m0 here. Gm2 m0 by what to write here? This distance, students, this distance d minus x. Okay, so we can write here d minus x whole square. What will happen? See, this m0 cancelled. See, m0 cancelled. That means we can see here. See, I am writing here separately. That means here this I01 is equal to I02 also. Both the things are there as I told that here. Is it? After that, what will happen that here? This g and g also cancelled here. That means we can write here, see please, m1 by x square is equal to m2 by d minus x whole square. When you will simplify this, now very easy, simple basic mathematics are there. This x will come d by square root of m2 by m1 plus 1. Plus 1 is outside of the square root here, na? So this will be the null point here. And whenever you are using this law, please remember that here, this x distance is always from smaller mass. From which mass? From smaller mass. From smaller mass here, okay? What I'm telling here, this m1 is less than m2, okay? m1 is less than m2, and this x distance is from which mass? From the smaller mass, okay? From smaller mass. Please remember that very well. Then you use this formula, no problem. Very easily your answers will come here. Okay, students? Next one, please, after that, let's see here. Now we are going to see the GFI of different bodies. Now, so see here, please here. GFI due to hollow sphere or spherical cell. So see here, please. Let mass and radius of a hollow sphere is capital M and capital R respectively. Now, first we will see GFI outside, then we will see at surface, and then after that we will see inside also here. Now, so what I told here, this is mass M and this is the center, now, and the radius how much here? R. Now students, first I am going to calculate the GFI outside. Now, so GFI outside means, let's take somewhere I have taken here. Point A outside here. So again I am telling the center to the observation point, I will write here R here. Now, so you know very well, whenever the observation point is outside, the total mass of the sphere can be concentrated where? It can be concentrated at the center here. That means outside means small r is greater than capital R, and here the total mass of the sphere can be concentrated where? At the center. So if we can consider the total mass at the center, that means mass to the observation point, how much distance? Small r here. Now, so in this situation I will write here this at point A, I out is equal to, very easy, see please here, Gm by r square and minus r cap. I told you very well why minus r cap is coming, because GFI always act towards the mass in the opposite direction of the r cap. Okay, r cap will be in this direction. So it will be in which direction? Opposite direction, at this side here. Now, so only minus sign is there. Okay. After that, student, second one, at surface. Where? At surface. At surface means where? Just outside. Just outside. Just outside means how much here? We will write here small r is equal to r. And here we will write here. So what this will become here? At surface. Now here, somewhere here, let's take it here. Here I have taken at surface here. Now. So let's take now this distance is small r here. Okay. So in this situation, students, see here please here, at surface is given by, what you write here? Again, Gm by r square minus r cap. This is at the surface. Now, and this is where? Outside. Now students, after that third one, if we see inside, this is somewhat tricky. This is somewhat tricky. Where? Inside. This inside. Outside surface and outside we have taken. Now inside here. So now see here please, inside. Inside students. So see here please here I have taken some other point here. Here I have taken some other, let's take this is point A, this is point B, this is point C here. And this distance how much here? This distance is smaller here. Now through this point R, I will take some sphere here like this here. If you have seen the gravitation video, acceleration due to gravity, maybe you know the basics very well. Now, can you see very well? Let me draw here the, okay, no problem. This mass should be somewhat symmetric actually. Na? This sphere should be symmetrical to this yellow line here. Na? But okay, no problem here. So can you tell very well inside mass how much here? The inside mass is 0. Inside mass how much? Again I am telling 0. So as inside mass is 0, as inside the sphere, mass m dash is 0. Hence what we can write here? I inside will be how much? This I inside will be 0 here. Now if in case I draw here the diagram here, see here please, let me draw here the diagram here like this. Now cycling like this, see. Now see, because the graphs they used to ask that here. Now graph. Now so see here please here I have taken like this here, this is R. Now and this side I have taken what? This side I have taken this GFI I here. So what is happening? Inside any GFI is there, inside GFI is not there. Outside and on the surface only GFI is there here. Now, so we'll draw here like this here, just the dotted line here. Now, so see here, this like this the graph will go ahead. Like this graph will go ahead. And here we will tell this is smaller equal to minus r, and here we will tell is smaller equal to capital R, and here we'll put the vector sign here. When we are taking the direction, this what to tell the graph will be downward. And if in case we are not taking the direction, here vector sign is not there, then you can take this graph upward also, no problem is there. Okay. So this is for which one? This is due to the hollow sphere here. Okay. After that, students, we will see due to which one? GFI due to solid sphere here. Now, so see here, please. Again, let mass and radius of a solid sphere is how much here? M and R respectively. Now, outside, surface and inside here. So again, students, I am telling that here outside and surface just similar to the previous one here. What I am telling here? Outside, if I write here the outside how much here? Small r is greater than r, that we have seen before also here, the same expression. I out equal to no changes, gm by r square minus r cap, just a previous diagram. Okay. Second one, if we see at surface means where, students? Just inside. Okay. Not inside, just outside, okay. So at the surface, what was the value was there? Same story, gm by r square, and here how much? Minus r cap. The main change will come here inside. Why? Because in case of hollow sphere, mass was not there, but here in this situation, inside mass will be present here. Na? So here you have to just remember that somewhat better. Inside, same concept you can apply for the planets also, na? Because planets are also solid here. Na? So see here, please, see the student. So see the students, here I will take here. Na? I already write this there, I will take some other color here. Na? So see, this is the center here. This is the center, and see, I want to calculate the GFI here. Na? At point P, I want to calculate the GFI here. This is R. So through this point, I will take here what? I will take here one imaginary sphere. Mass of this imaginary sphere, how much here? M dash here. Now, so if I draw here, the total mass can be concentrated where? At the center M dash, and see this distance. This distance, how much here? This distance is small r here. Okay. And again, I'm telling GFI at point P will be due to the inner mass here, this pink color mass. But if you talk about the outer shell, due to outer shell, there is the no GFI. This concept you have learned in acceleration due to gravity, where inside due to depth here. Now, so students, inside this GFI is given here. I in is equal to what you write here? Gm dash by r square. Okay. And here minus r cap. Can you tell what is the value of the M dash? As I told you very well, M dash means the mass per unit volume, 4 by 3 pi r cube into volume of the inner sphere here. Nah? So 4 by 3 pi, cancel here. Okay, students. So when you will put all these values here, then it will come here. See here, please. Gm into r by, it will come here r cube, and here minus r cap here. Now you have to just replace the values here. Now students, after this, if I draw here the graph here. Now just let me write this, and here itself I will draw the graph here now. So see here, please, here again. This is, I will draw here like this. Like this. This is also like this. I will draw here. So students, here, please, here. Let me take here. This is r, and this side is I. Vector form here. So again, just like we have seen the gravity due to the solid sphere, acceleration due to gravity, in the same way. This is the small r equal to capital R. This is small r equal to minus r here. And this one will represent the inner side here. So inside what is there? Directly proportional to r here. You can see here the I is directly proportional to r. Why down the axis? Because minus r cap is coming. After that, if you see outside, what you can see? Inversely proportional to r square. That means how it will go? It will go like this here. So this is the GFI due to which one? This is the GFI due to the solid sphere here. Okay, again I'm telling, if vector is there, down the axis. If vector is not written, the same graph you can draw upward also, no problem here. Now, okay, good. Now we are just reaching to the end only. The last one is what? GFI on the axis of circular ring. Very, very important for the 12th also. 12th also will be there. So see here, please, here, students, here I have taken one ring here. This ring in which plane? This ring I have taken in YZ plane here. Okay, this is X, this is Y, this is Z. Now this ring I have taken in a YZ plane here, and here I have taken one observation point P, and the distance of the observation point, from the center of the ring, how much? X. Now students, to calculate the GFI, because GFI is the vector quantity, what we have to do? This GFI concept is applicable for the point masses. Directly we can't apply for the ring. That means what we have to do? We have to take one very small point mass here. See here, I have taken very small point mass dm. Okay, total mass of the ring is m, and anyhow the radius is r only here. So due to this mass dm, see here, please, here. Due to this mass dm, the GFI will be in which direction? This direction here. So due to mass dm, this is GFI, di. Now by the symmetry, see here, please. If here also, if I take the mass dm here by symmetry, so see here, please, here also, Here also what will be there? This will be the di here. Is it? Now after that, let's take here students, this angle is theta and this angle is theta. Now can I resolve here this di here? So see here please here. This side, this di will be how much here? Di cos theta. Here I have taken only two masses, but multiple masses will be there, the multiple point masses. So all this di cos theta will be this side here. And this direction di sin theta. Now, and this side also, what is this? This side also di sin theta here. So what will happen that here, due to multiple masses, all this di sin theta will cancel out. And what will happen? All this di cos theta will add up and we will get the resultant GFI towards the center of the ring here. Okay. So again, let me read now because already I have explained the basics here. So see here please here. Let mass and radius of a circular ring is capital M and R, as I told already. GFI di at a distance x due to small mass dm of a ring at point P is given by here. Now let's take this, and distance is r. So what is the di value? Di value g into dm by r square. This is the di value due to which mass? Due to mass dm here. Now only magnitude is there. After that students, see here please, next one. See here please. GFI at this point P is along the center because vertical components di sin theta will cancel out, but horizontal components, that means di cos theta, will add up due to symmetry of the ring. Now GFI due to point P due to the ring is given by here. Now, so total GFI at point P is given by here. See please here, IP is equal to integration of di cos theta here. Okay. Now let me put the value here. Di how much here we have got very well? G into dm by r square. Now after that, what is the value of the cos theta value we want? So see here please, the cos theta value how much here? In this triangle, can you see the triangle here? This is x, this is small r, this is capital R. So cos theta is given by what here? The cos theta is given by x by r here. Now this cos theta I am going to put next one here. Now cos theta correct now? Again let me check. See here mistake happened. Now see here please. Base by hypotenuse, na? So see here please. Cos theta is what here? X by small r. Na? This kind of mistake should not happen actually. So see here please here. This one here, cos theta I will put here, na? So let me just put the values here. So see here please here, G into dm by small r square, and cos theta how much here? X by r here. If you will see that very properly diagram, this capital G, small r and x will be constant because each and every mass on the ring is equidistant from the observation point. So what this will come here? See here please, gx by r cube, and here integration of the dm here. Now, so students, when you will simplify this here, now, so this ip will come here, how much here? G into integration of dm, how much here? M. So gm into x, and what is small r? If you will apply the Pythagoras theorem, this small r will come here, r square plus x square, or we can tell r square plus x square power 1 by 2, and here 3 is there, that means what we can write here? R square plus x square power 3 by 2. This is the GFI at the distance x from the center of the ring. Remember the formula, this will be used in a 12th also. After that students, cases of GFI due to the circular ring here. First one, at the center of ring. Where I am telling? At the center of ring. So students, at the center of the ring, value of x how much here? 0. So the moment in this formula, let me write here the formula again, gmx by r square plus x square power 3 by 2. Just put x equal to 0. That means what will happen that here? At the center of the ring, GFI will be how much? 0 here. Now, so see here please, if I draw here the one ring also having the mass m, then at the center, due to different masses, what will happen? All this GFI will be like this here. Now, and what will happen that here? At the center, their vector quantity, they all will cancel out, and the GFI will be how much? 0. And second one, the last thing here, maximum GFI. Maximum GFI here. Now, so for maximum GFI, what I will do here? This one here, this di by dx will be equal to 0. No need to do the mathematical thing, they will not ask that here. So when I will do di by dx equal to 0, then I will get here x equal to plus minus r by root 2. At this point only what will be there? GFI will be maximum, and this maximum value of the GFI, I max, is given here 2 by 3 root 3 into gm by r square there. Okay, so this is the maximum GFI. If in case I draw the GFI due to the ring here, so see here please here, due to the mass, no, GFI will be always towards the mass here. So r equal to capital R, r equal to not capital R and all, we'll write here R by root 2 here. Now just here please, as I told you, this one here, x equal to what is there, R by root 2, and here how much is there, x equal to minus R by root 2 is there. Okay, so what will happen that here, if I draw here from center of the ring to R by root 2, what will happen, it will increase like this, not a straight line, little bit curved here. After that it will go like this here. After that it will go like this here. Okay, so this is the GFI diagram due to the which one, ring. So students, now we have just reached to the end. So students, in this class what we have seen, we have learned everything about the GFI. Okay, so students, I hope so you are regularly watching the gravitation series video. Just keep on watching and kindly comment, share and subscribe to my channel. Thank you so much.